Good afternoon, everyone, and welcome to my talk on modern testing for modern developers. So my name is Amanda. I am a senior consultant with a software testing consultancy called Planet Software Testing, and we offer a whole range of test services. And if you'd like to know more about those, you can come chat to me later. But apart from that, I'm a singer, dancer, photographer, and also study. So what are we actually going to talk about today? So who has seen one of these before? Who hates them? Yeah. These are the sort of test case where all the details are step by step and they're run by a test team who sit in a different room, maybe even a different building, a different time zone, a different country, where you throw code over the wall at the testers and then they throw defects back. And this particular style of test is kind of the first test that most people learn how to do. And sadly, a lot of people never learn how to do testing any other way than this. And this type of test, it's still valuable. There are certain environments and times that we really do need to document testing in that step-by-step way, but not always. And look, for me, one of the biggest problems with this type of test is that the test team, they get documents. They sit there, they analyze them, and then they write a test. And these tests are written either before or while the code is being developed, and there's always changes in the requirements and specifications as that code's being written. So then the testers have to go back and edit the tests, and there's a lot of upfront work and a lot of waste that kind of goes into this sort of test case. And another important thing is these are a form of debt. Like technical debt, because you've done a lot of work and they need a lot of maintenance, if they're not maintained and they turn into debt, it means that you can run the tests and then they fail because the code has changed, because our needed configuration has changed, and then test teams are raising defects that are rejected because there'd been changes, and that's just a whole lot of extra waste on top of the process. Like I said, I don't want to entirely knock these sort of tests. They are valuable at times, but like development has moved on from previous styles and things that they've done, I'm pleased to be able to tell you that testing is moving on as well. So what are we going to be talking about today? Like I said, testing has moved on. It's not the same thing it once was. So we're going to go into a bit about what testing is anyway and what it looks like in the kind of modern environment. And then I'm going to go through a bunch of different techniques and ways that we can be testing, including risk-based testing, test heuristics, automated testing, and exploratory testing, as well as giving you some information on where to find out more about these things. So, that test case I showed you just before, a lot of people kind of have the perception that having a test case means that you're testing. But I'm saying that we don't need a test case. So if we don't need that test case to be doing testing, then what's testing? So there's a bunch of different people who have different ideas on what testing is and what it looks like. This is a really kind of technical definition from the ISTQB, which is the International Software Testing Qualifications Board. They're one of many groups who try and define what testing is and what it looks like. Now, there's a few things I do like about it. It is very wordy, but I do like a few things about this definition. It talks about how testing is across the entire life cycle. So that means we don't need running code to be able to do testing activities. We can look at testing from a static perspective, where we look at documentation, but we also look at code that hasn't yet run. And we can test that, review it, do walkthroughs, do showcases of our intended functionality to people. And that's still a form of testing. We talk about static and dynamic, so I just talked about static testing then, but also dynamic, where we have code that we can actually run. We look at software and related work products. So when it talks about related work products, it's things like our user guides, our training materials, things that help people to use the software. Those can all be tested as well. We look at whether they satisfy specified requirements and to demonstrate that they're fit for purpose. Does it meet our business stakeholder needs? Another definition I really like is by a woman called Claire Reckless. She's from the UK. There's a really detailed blog post that covers all of this, which is what the link is for. But she talks about kind of characteristics of testing, where testing is about investigation, about exploration, mitigation. So that kind of testing is, when she talks about it being investigation and exploration, it's not just that we go and run a specified set of test steps. We go into the software and work out what it does. We work out what it is, what it does, and how to kind of get to all different areas of it. We see if it does anything that it's not specified or that it might do that we didn't ask it to do. And that's where mitigation comes into it. When we start finding defects and issues, we work out how we can reduce the impact and severity of those. I really like her fourth point where she talks about testing being valuable. Because I know a lot of people, and I saw it on some of your faces when I showed the test case, I just like, testing, I know I need to do it, but... And I think one of the things with the large, bulky test case style of testing is that it's been seen as a time waster and not so valuable. Because what's it really giving us? Because they're sitting there and they're doing all this stuff and it just takes forever. Communication is so important to me in testing. It doesn't matter if we find a defect if we cannot properly communicate it, both to our development team, but also to our business stakeholders. In terms of, does this have value to fix? Is this going to affect their day-to-day business operations? And the last one I really love is about it being potentially infinite. Through any path, any type of software, the paths that we can travel, the data that we can use is potentially infinite. We cannot feasibly test everything, even when we automate everything. So it means that we need to then look at ways to identify what it is to actually test. But these have both been kind of a bit amorphous ideas of testing. They're nice principles, they're nice ideas, but to me it doesn't really dig into what testing is. There's another group of people who have created a course called Rapid Software Testing. And I really like this particular definition. Now, this isn't defining testing, it's defining when testing is done. However, it does drive a lot of my own personal philosophy around testing. So they talk about how do you know when we're done? When management decides that has enough information to make an informed decision about the benefits and risks associated with the product, and they decide to release it or reject it. Now, I take a bit of a broader picture than this. I don't just look at management, I look at all of our stakeholders, because ultimately the stakeholders are the one that matter, and our stakeholders can be users, they can be our operations teams, they can be a wide range of people from across the business, but they don't necessarily fit into those management roles. Because generally speaking, testers aren't the ones who are going to be making that decision about whether we can go live. So what I particularly like about this one is that we're looking at making informed decisions. So then testing becomes about providing that information to people so they can make those informed decisions about whether to release, what the risk is in the software, and whether it does what it needs to be doing. So, given what I've just talked about with those three different definitions, can anyone tell me where they think testing fits into this typical DevOps lifecycle? Sorry, I had heard someone go every second step. No, the answer is definitely everywhere. But what the testing looks like, what the focus will be, is different at each step of this process. Obviously, because that testing becomes part of that every step of the way process, it's an entire team responsibility and not just the responsibility of someone who might be in that tester or test engineer role. And what this testing looks like, it's different at every step. So if we look at, say, our production deployments, there we go. The testing we do there will be around observability and monitoring, as well as deliberate production tests, where we try things out and make sure that the code that we've deployed was deployed correctly and that it functions the way we expect it to. And I know for a lot of testers, the idea of testing in production is quite scary. because largely we work in an imaginary world where we're only looking at test environments and test data. But who does testing and what form that testing takes does vary a lot across the life cycle, but it's all testing. Okay, how do we test? Personally, I take a pretty eclectic approach to testing. And for me, that looks like a couple of things. One, I am context-driven. So that means I look very much at the context of a particular project, of a piece of work, and work out what that means, and it means that I don't test the same thing the same way every time. Take, for example, a Salesforce implementation, which, Salesforce is pretty hot at the moment. Depending on what that Salesforce is used for, you could end up testing the same piece of software two very different ways. I'm also risk-based, which means that I look at the particular set of risks that a program has and focus my testing around those risks. So take that Salesforce program. It means that you're going to test a piece of software that's used for, say, immigration purposes. That same Salesforce that's customized for that will be tested in a very different way to what we might do if it's a customer relationship management for a toy train shop, for example. There's different risks, there's a different context, so we'll look at doing testing quite differently. So, context-driven testing. Like I said, it doesn't happen in the same way every time, but it takes into account the specific project, including the including the needs of stakeholders, and to work out what the best approach is for this campaign. Now, how do you find out that context? You start talking to people. You speak to your stakeholders, and the more skilled you are at building those relationships, the more you're able to find out information about what particular users' needs are and what the context of a particular project is. So, and it means you'll get better at identifying the context and that risk. Sorry, my screen is doing something really weird. So with that Salesforce example, we'll focus very much, if it's an immigration system, we'd focus very much on the correctness and completeness of that information displayed. Because if it's not correct, someone could be detained unlawfully or removed from the country if their visa information is displayed incorrectly. This could have a pretty serious effect on people's lives. Now, if we go to the toy shop example, where it's a mum and dad toy shop, we'll test their webpage in a very different way, where we're looking, can people make sales? But ultimately, it's not about life or death for someone's particular life, which is good. And risk-based testing, how do we do that? Again, it's really about communicating people and talking to them and finding out what the risks are. And it might be sit down and have a workshop with people. There was one project I worked on not long ago where we're sending electricity bills to a system to be paid, from one system to another. And I sat down and had a risk workshop with the team and went, right, what do people perceive as the risks? Well, obviously, business are like, we want to make sure that our power bills are paid so the electricity stays on and we can continue functioning as a business. That's their biggest risk. So then we sat down and looked at the architecture of the particular system and went, okay, this system is going to be sending to our finance system every day information about the bills that are arriving and then need to be paid. The finance system will pay them. Cool. Okay, what if that interface in the middle is broken? And the finance system went, cool, we will just process the bill when it comes in. Yep, fair enough. But then we're asking the bill collection system, okay, when you send the bill information across, do you send it every day? Do you send it, and if it doesn't get processed, do you send just the changes or all of them that are waiting, or what do you send? Like, okay, well, we'll send the changes that come through every day. Fair enough. Went back to the finance system and went, okay, if there's multiple files waiting to be processed, what happens? And they're like, oh, we'll only process the most recent one. Now, from that example, we'll have bills that have been coming through and waiting to be paid, and then not getting paid because that system will only process one. So that's a pretty big risk, and the impact of that would be that in the end, you have power bills that are not being paid and the risk of disconnection of that electricity, which, not a great business outcome. So again, it's about sitting down and talking with your stakeholders and finding out what is important to them and what do they need to be working. Then risks are rated. We look at what the impact is going to be. So in that electricity one, impact of the power bills not being paid is obviously that our power it gets disconnected and we can't work as a business. For the immigration example, an impact of a particular risk might be that someone is removed from the country. Very, very different kind of life-changing effects of different risks. But so the impact we need to look at. And then we look at the likelihood. How likely is this to happen? In the case of the data being sent between systems, we knew that our middleware system wasn't particularly stable at the best of times. So the likelihood was particularly high of that happening, that it wouldn't be there and that we'd have some bills backed up that then wouldn't get paid. And we look at the impact and that likelihood together to work out what that level of risk is. And it's important to also note that with the likelihood and risk, they're also contextual. Something might be quite common in some environments and less common in others. So this all goes back to that context where we don't do the same thing every time. We look at what our particular scope of work is, we look at the environment it lives in, and then begin to look at those risks. We can't just go in and do exactly the same sort of testing every time, because in some times that will be over-testing and some that will be drastically under-testing. Okay. Test automation. Now, I'm not going to tell you what tools you should use for this because I'm not aware of your context, your tool stack you're using or anything like that. But I'm going to talk about some of the ideas behind it. Now, who here thinks we can automate testing of absolutely everything? And who realizes that this is a really leading question based on everything I've said so far? And I absolutely think the answer is no, but it really depends on your context. I'm glad you've been listening. So as I've set up the top, test automation can answer yes/no questions to things that we know to ask. And that's really important. It can only tell us what we ask it. And it can only say yes or no. Is this button there? Does this do what we expect? Does it answer that function? That's all it can tell us. It doesn't mean automation is bad. Automation's really important. We just need to use it in an appropriate manner. So we need to focus our automation where it's valuable. So it could be business processes that run all the time and that we absolutely need to have working. It could be complex scenarios that we know we can automate and that need, like I said, absolutely need to be running. And if we need to run a test repeatedly, same sort of thing over and over again, it's absolutely a great candidate for automation, including test regression, things like that. But quick word on automated regression tests. You can't keep the same set of automated regression tests all the time because they will eventually not give you any useful information. There's a concept in testing called the pesticide paradox, where, same with a pesticide, if you keep using it over and over again, you begin to get bugs. I'm talking about actual insects at the moment. You begin to get bugs that are immune to that pesticide. And you can use the pesticide over and over again, but it won't be killing any bugs. And the same thing happens in technology. If you're using the same set of regression tests over and over again, it's not going to provide you with information. So you do need to change them up every so often. It might be that you change the data that's being used in the tests. It might be that you produce a slightly different workflow that has the same business impact. And that's when you begin to see repeated value out of your automation tests, when you do change them from time to time. Now, has anyone seen this before? And the tester down the front says yes. So this is the test automation pyramid. And this is a general concept, an idea of relative amounts of automated tests that we should be doing in our test campaign. Now, a lot of people hate this concept because they kind of get the idea that it's about all of testing and not just automated. I particularly love this because it's an idea, an illustration to kind of show one single concept. where we should be doing as much of our automated testing as low down and as early as possible. And as the system gets more complex and as the user interface comes into play, we do less of that, because UI tests are notorious for being flaky, for being failing all the time, even if something's not wrong, and they're quite a lot of debt to be dealing with. They need a lot of upkeep, they need a lot of love, and it's not necessarily the best use of our time or money. For me, I add something to this test automation pyramid. Inverted pyramid. And what I have the other one for is the level of human testing. So as we go through a project, as we go through a piece of work, the human involvement in testing gets higher. So very little involvement at that unit test level, because we know we can automate a lot of that. We use a lot of TDD approaches, and it's great. But at the end-to-end or the UI level, that's where we really need to be looking at having as much human involvement as possible. Because if we go back to that whole idea of automation can only give us yes/no answers to questions that we know to ask, it's through experimentation and human work that we can find out more about the software. Hence why I'm on to exploratory testing. So a lot of people associate that human test element with those big, bulky test cases I had up front. I'm really pleased to be able to tell you it's not the only way. So there's this concept of exploratory testing, which this definition is from that rapid software testing I mentioned earlier, where we have simultaneous test design, execution, and learning. So we don't sit down and write all those big, bulky test cases up front and spend hours writing them. We have an idea of what it is we want to test. We come up with some ideas, and then we design and execute at the same time. And I'll show you an example of that at the moment. The other thing I really like about this is that concept of learning. We are not just going in and having a look and making sure that it does particular things, but we're also learning about what that software is doing and what it's telling us and what information that we can be giving to our stakeholders. So, I know a lot of people are very familiar with the whole idea of exploratory or ad hoc testing, and it's all just someone goes in and they have a bit of a bash around and give it a go and see what happens. Modern exploratory testing is not like that. It's a skilled activity where we use experience and our knowledge to design our tests. Now, this thing we've got on the left side of the screen is a test session sheet. And so what we do with this is we sit down and we go, well, this one that's displayed is for localization, but take a login page, for example. We will sit down and go, right, it's a login page. We know there's a username field, a password, login button, and a forgot password button. So we go, okay, if we want to test this, we need to be able to look at incorrect password, a correct username and password, an account that doesn't exist. We need to check that the login button works, that we can go to the register page. And in that 10 seconds or however long I was talking, I've designed 5 different tests without sitting down and doing that big upfront work of writing that test case. They go then go on my session sheet, and they're my starting point. That's not my whole testing. That's my starting point of what I'm going to be looking at, what I'm going to start with, and then I'll explore from there. It might be for a password, I try the different character types. I try special characters and letters and numbers, but then also see what happens if I use an emoji. What happens if I don't have a password in there at all? We're still going through a similar process, but instead of it all being set up front in our test case, all written down, which leaves the tester no room for creativity or thinking, we're emphasizing the creativity, the thinking, and the exploration as being the really important parts of the test process, because that's what differentiates us from those automated tests. So, apart from those basic things that I've talked about, and apart from getting ideas from our specifications and things, where else can we get those test ideas? One of them is through a concept called test heuristics. This is rules of thumb that can provide us with information and sources of what's good to test. What I've got on the left is a concept called the heuristic table of testing, and it's a whole list of different heuristics that we can use, and I'll explain one of them. So the one I'm going to explain is called SF Depot, San Francisco Depot apparently. And it basically SFDIPOT. A series of letters that will give us some information on what to test. So we can look at the structure of a piece of software. How is it set up? Do we have databases? Do we have middleware? What's the whole scope of what we need to test, and what's that structure looking like? What's the function of it? What are we actually using that software for? How does it work? What are we trying to achieve with it? The data. Are we just using text data, pictures, sounds, music? Are we looking at specific formats that they're stored in? Is the database a SQL database, or a graph database? How is this data stored? How are we going to be using it? How is it retrieved? Interfaces. Do we have interfaces to other systems, or is it self-contained? Are they external or internal? Do they go via files or XMLs and SOAP messages? The platform, is it based on, say, a Salesforce implementation where we can get a lot of information, or is it something with, grown more organically in-house? These aren't the only questions that we can ask about these, but these are starting points. Operations is very much about, how does it work? What do our operations team do? And what sequences can we take through the data? And time, time zones. Do we have batch jobs that run overnight that are going to affect the system performance? This is a starting point, but as I've talked through those, there's lots of different things that you can pull out, ask questions about, and start discovering more information about the way system works. So for time, a really interesting one I had was, I worked on a HR system where the servers are in west coast of US, which means that any operation doesn't take effect until midnight of that night in the west coast of US, which is about 5 p.m. our time. So you create a new person, they started today, but they don't exist till 5 p.m. because you have to wait till it rolls around till midnight. And that's a really useful thing for our business and product owners to know, because then they have to change their business process owing to the fact that they're in Australia, start everyone a little earlier in a weird way, so that their account and they exist on their first day for work. There are many. I think my favorite named one up there is called Slime, just because that's cool. It's the purple one. But this is available on the internet. You can have a look at it, and it goes through lots of different concepts of ideas of ways to think about testing and things to question and ask about to design tests. So I really love this tweet from Lynette Creamer. She basically says that automated and exploratory testing isn't a competition. We need to consistently advocate for both of them. We can automate lots of things and run those tests really frequently, but we need to assess risk in real time by exploring. Both have intense value and they work really well together. So, this is awesome. This is really great. How do we learn a bit more about testing? So, obviously, I work for a software testing consultancy. We run training courses. If you'd like some info, talk to me later. I really love meetups for learning more about testing. Sydney has a couple of really fantastic meetups. I know people who run them. Sydney Testers is a great one, and there's also a quality engineering meetup. They're both really great ways to learn more about different ways to test. The quality engineering one is a really interesting one because it's very much not about having testing as a separate phase, it's about building that quality into that whole life cycle, which is very much what that DevOps life cycle I showed you earlier, which is by a great great guy by the name of Dan Ashby, has created. But they're a really good way to just learn some more information, be exposed to some new ideas, and find out some more stuff about testing. There's a course called Rapid Software Testing, which is where I've gotten some of these ideas from. It's only held in Australia once or twice a year, and I think the next time is actually next week in Sydney. But If learning more about this sort of stuff interests you, keep an eye out for that. There's a really, really amazing book by a woman called Katrina Clokey, who's from New Zealand, about testing in DevOps, and it goes into a lot of these concepts in a lot more detail, and she has a lot of great stuff about testing in production. And there's a link to that book there. Some of my favourite bits. Okay. I really, really like the use of games as a way to learn testing. The first link I've got there is a series of games that have been specifically created to learn about exploratory testing. They don't provide any information, and you need to explore the software and find out what it actually does. Work out what it does, and come up with your own simplest rule as to what's actually happening. The second one is not a whiskey store, as the link says. It's a bit of a lie. But instead it's a game where you treat stuffed toys who are in an insane asylum, who'd been mistreated and mishandled, and need some love and treatment. Now, again, it's an exploratory game, I find, because you have to go in and work out what's wrong with them. And they give you different information and different feedback depending on what sort of treatment you give them. Sadly, that's a flash game only, so it's getting increasingly difficult to run. Black Box, which is an iOS game, only has one rule, and that's you don't touch the screen. And instead you need to, and that's the only rule, that's the only instruction, and instead you need to experiment with your phone, including touching the volume buttons, and one of them you have to sing into it. And you solve the games and puzzles by experimenting with the different functions that the phone has. And for that one, for most of these, there's actually, if you do get stuck, there are guides that can explain what's going on and help you out. But, you know, if the point is to learn more about exploring, just start without them. And then another way to learn about testing is to pair with testers. If you have testers on your team, I know the tester-developer relationship is a bit acrimonious at times, but go to your testers, make friends with them and go, hey, I'm really interested in learning a bit more about testing. Can we pair together? And I'd start potentially with the tester as the navigator and the developer as the driver, and start talking through a piece of functionality you're working on. I've had a huge amount of success with this particular one when I was working with a team that had no testers at all except for me. There was a team of 45 developers and myself. So I'd sit down with my developers and go, okay, cool, tell me about what you're working on. And one of them was trying to make something like validate a file coming in from Excel, validate them, and then process that data. And she was puzzling over how to try and make some of it work. I'm like, cool, sit down, we'll talk about what you're trying to work through, what path you're going through, and we'll see if I can help. And what she was trying to do was return a single error message to the user, reject it, and keep going. I'm like, okay, let's talk through this. If you were a user and you got an error message, how would you feel? And she's like, well, obviously I need to fix it. Great. What if there's 6 errors in the file, for example? How many error messages is it going to display? And she's like, oh, I'm trying to get it to just do 1. I'm like, okay, but how is the user going to feel when when they've gone through the effort, they've changed that 1 row, they upload it again, try and validate it, and it doesn't work, and they've got another error. And she's like, yeah, that's going to get really frustrating after a while, isn't it? So we changed the path she was working on to be kind of more kinder to the user, and the user would then get a list of error messages that would relate to the file, so they could change it once, upload it, and be happy that it was going to work. Another example of that is I was working with some ID numbers with a developer, where it was always going to be 3 letters and 12 numbers. Didn't matter what it was about. It was always going to be the same 3 letters and then 12 numbers. And he's like, we begin talking through what we're going to be testing, how he might go around testing. He's like, okay, I'll just put in some numbers. He's like, I'm getting unhandled exception errors. I'm like, well, that's because it's expecting 3 letters and 12 numbers. I said, have we considered doing some client-side validation for that, making sure that it's only validating that only that data gets sent? He's like, oh, but you can work around that and server-side's better. Except if you'd use both together, it means that you're getting a better user experience because they're getting that error message right up front, and you're still getting all the benefits of having that server-side validation. So sitting down with them, sometimes it doesn't have to be in much detail, but sitting down with your sitting down with your testers and getting them to talk to you about the stuff you're working on. Getting some information about what they'd look at, because we do see, as testers, we do see some of the same defects over and over again. So if you sit down with your testers, have a chat, find out what they're looking at, then that's something that you can learn to help your coding be better as well. And if you get the opportunity to pick up a user story and try it to do testing, give it a go. Ask your testers for help if you need to, and try it out and see what you can learn. Because, like I said, this whole exploratory concept is very much about that simultaneous design and execution of tests and learning. That's a super important part of it to me. With these games, something to go back to quickly, if you do find a defect, or if you find a problem, or if you think this is a particular rule, ask yourself, what's telling me that? How do I know that that is a problem, or how do I know that that's the cause? What information am I drawing those conclusions from? Because that's the same sorts of questions that good testers are asking themselves when they find a defect in your software. They're not just going, oh my God, it doesn't work. They're actually, good testers are sitting down and working out what it is that tells them that that's a problem. Why is it a defect, and what have they learned from that? So, I have 3 kind of main takeaways from today for you all. The first one, testing. It's the process of getting information about software and the related work products so our stakeholders can make informed decisions. Testing is about providing them with that information and providing them with information about risk. To work out what to test, look at the context of the work and at the risks involved in making this change. And also look at the risks involved in not making the change. What's the impact to business if we don't put this software live? And lastly, automated testing and human testing both have pros and cons, but they work super, super well together. Thank you.